Well, hello, my pretties. In this video, we're going to talk about the determinant and how to find the determinant of a 2 by 2 matrix. Now, once upon a time, I used to get this word confused with the word discriminant, and they have nothing to do with each other, so far as I know. Anyway, uh, this is only going to apply to 2 by 2 matrices. All right, if it was a 3 by 3 or 4 by 4, it gets much more complicated, and we would just use a calculator to do it. But this is so fast and easy, I'm going to show you how. So the determinant, I'll show you later, but it determines whether or not something can be solved, right? It actually determines whether a matrix is invertible or has an inverse. That's what it does. But for a 2 by 2 matrix, so let's say you've got any 2 by 2, A, B, C, D, to find the determinant, you're going to multiply the ones in those top left and bottom right corner, and then minus the other two numbers. Okay, so let's do that real quick with this example. We're going to do negative 3 times 7. All right, so that is negative 21 minus, and then we'll do 5 times 4. All right, and this equals negative 51. And that's it. We just found the determinant of this 2 by 2 matrix. So it's so easy. I'm only going to do one example there. All right. Now, to show you a little bit for how you can use it to see if something can be solved, what we're going to do is we're going to multiply these two matrices here. So this is a 2 by 2 matrix, and this other is a 2 by 1. It's got 2 rows and 1 column. Now, I don't think I've mentioned that whether or not two matrices can be multiplied. They can't always be multiplied. What it has to do with are these two inside numbers. All right, as long as those inside numbers match, you are able to multiply them. In fact, all right, when you multiply them, the answer is going to be a 2 by 1 matrix. You use these outside numbers to see what your answer matrix is going to look like. And I'm actually going to leave this blank over here on purpose. You'll see why maybe. So in order to multiply it, I'm going to do this row, and I'm going to multiply that by this column, or I'm going to find that dot product. So it's going to be 2 times x, that is 2x, plus 3 and y, so 3y. There we have it. And then we're going to move on to our second row. It's going to be 3 times x. So we only have one column to play with over here. Plus, imaginary plus sign, negative 6 times y, negative 6y. All right. Now, if there were, I wrote it out like this, so hopefully you can see what this is sort of related to. If you had a system of equations, 2x plus 3y equals, 12, and the bottom one here, let's say it equals negative 7. All right, you can represent this system of equations with a matrix, all right, with a matrix equation. But really, you're going to see it only has to do with this first matrix. This is the one that really matters. We'll call 12 and negative 7. So what we're searching for are an x and a y, such that when we multiply this matrix by x and y, we get 12 and negative 7 as our answer. That's what we're searching for. Now the determinant tells you whether they even exist or not. All right. So the way it works is if you find the determinant of this square matrix, if it is not equal to 0, as long as it's not 0, then this system of equations can be solved. Okay? If it is equal to 0, then this system will never be solvable. All right? It happens because they're parallel. Anyway, let's do the determinant real quick. We'll tell 2 times negative 6, that's negative 12, minus 3 times 3, that's 9, and you can tell this is not equal to 0. Now, all this tells us is that this system of equations can be solved. And in fact, no matter what numbers you put on the right side, no matter what they are, it can be solved. It all has to do with this x and y pattern down below. Basically, if the two lines are parallel, all right, if you have two parallel lines, they never cross, and so there's no solution to that system. But this right here, when that happens, when they're parallel, you end up getting this determinant equaling 0 stuff. Okay, so real quick, here's the question: can this system be solved? So to check, I'll write a little matrix: 3, 6, 4, 8. I don't care about these too much. Can it be solved? We'll do the determinant to determine that. 3 and 8 is 24, minus 6 and 4 equals 0. Because the determinant is equal to 0, I know that this cannot be solved, this system of equations. All right? If you were to graph these on Desmos, you would see that they're two parallel lines. All right, so that's the determinant. It's super easy.